Is my voice and the screen is visible?
Yes, sir.
Yes,
Okay,
sir.
okay, right. Thank you. So we were seeing displacement, right? So tell me something about displacement, what we have learned in the earlier class. What is displacement?
Change,
What, ma?
change the position with respect to time.
Okay, who's that? Your name, please?
Disha, sir.
Disha. Okay. So change in position with respect to time is otherwise called as what? Motion, right? So
Yes,
when we
sir.
say a object is motion, we'll say that is change in position with respect to time, right? Change in position with respect to time. Okay. So what displacement means is nothing but the change in position. Okay. Displacement is nothing but change in position. So it is del x, right? Del x. So del x is equal to x2 minus x1, right? So x2 is nothing but what? Final position. X1 is nothing but initial
Initial
position.
question.
Yes,
Initial
yes, initial position. So what can we say that change in position? We can say that it is nothing but a difference between the final and initial positions of the object that is in motion. Okay, we can say it is a difference between final and initial positions of the object. Okay, that is in motion. Okay, so other characters of displacement. What are the other characters of displacement that we have seen in the earlier class? Displacement is nothing but a vector quantity, right?
Yes, sir.
It has direction and magnitude also. Then another characteristics. What about its values? It can have positive, negative, and even zero values, right? So when can the displacement have positive value? That is, when can del x be positive? We have already seen that is x2 when x2 is greater than x1, right? And
Yes.
when yes, and when will be the displacement be negative? When x2 is lesser than x1, right?
X1.
Yes. And when is del x can be 0?
Both value will be same, sir.
Yes, x2 is equal to x1. Great. Okay. So we have seen the operation OP, no? Displacement O to B. That is, a car was initially at O. This is a car. It was initially at O. Okay. And it has traveled from here to here, OP. So what is the displacement here? So displacement del x is equal to x2 minus x1. What is x2? That is final position. This is the final position. Okay. Because that is the, the final point. And what about the initial position? This is the initial position, the car where it started. Okay. So we can substitute the x2 is nothing but 360 minus x1 is 0. So what is the answer? 360 meters. We have to write as plus 360 meter. Since displacement is a vector quantity, we have to write it as plus 360 meter. It depends on direction. Okay. It is dependent on direction. And we have seen earlier that path length, OP, that is distance. Excuse me, just a moment. Okay. So path length, that is OP, right? That the car was at here. Okay. It has traveled from O to P. So what is the path length here? What is the path length here? O to P.
360 meter.
360 meters. Because path length is nothing but the total distance traveled, right? Total distance traveled. So here we can see for the For the distance OP, for path length and displacement is equal, right? For the distance OP, O to P, the car's displacement is equal to 360 meter, and car's distance is equal to 360 meter. Both are equal, right? So distance is equal to displacement. We have discovered some conditions also. What are the conditions? Could you remember? When can distance be equal to displacement?
Motion should
Motion
be
in a
in a
straight.
straight line, sir.
Yeah, first condition is motion should be in a straight line. Then,
It should be along positive direction,
very
sir.
good. So the motion should be along a positive direction. So when that happens, when the motion is along a straight line and it is along a positive direction, then what we can say, distance will be equal to displacement. Okay, distance will be equal to displacement. So clear?
Yes, sir.
Okay. So we'll go to another things, that is, so we can say like this, no? Um, so we can say like the magnitude of, just a moment. Okay. So here we can say the magnitude of displacement may or may not be equal to the path length. Okay. The magnitude of displacement may or may not be equal to the path length. Here we have seen that is it is equal to the path length, no? Distance is equal to plus 360 meters. So magnitude of displacement, this is the magnitude of displacement, right? It is equal to the path length. Okay, that's what the definition says. And for this operation, that is PQ. Okay, PQ, or we can say we don't have to do this PQ, we can straight away go to this operation, that is OP plus PQ. For instance, the car is at here, so from here it travels to here, P. Okay, and then it travels from P to here, Q. Okay, so this is the motion. The car starts initially from origin O, and from there it goes to point P, and then it comes back to Q. Okay, so what will be the displacement? So what will be the displacement, ma? Del x is equal to x2 minus
X2
x1.
minus X1.
X1. So what is x2 here? Okay, what is x1? The initial position is this, right? The car started from here. Where it has ended, the journey ended here, no? At Q. Okay. So for the motion OP plus PQ, this is the initial position, this is the final position. So x2 is nothing but 240 minus initial position is 0. So 240 meters. Are you clear?
Yes, sir.
Okay, any doubts on this? Okay,
No, sir.
so okay. So for the same thing, what will be the distance or path length? Calculate the path length. Anybody? Calculate the path length now and tell the answer. Path length for the motion between the distance OP plus PQ. The same, so the same distance OP plus PQ. Instead of finding displacement, we have already discovered displacement. So what will be the corresponding path length?
480.
480, sir.
480. Very good. So OP, that is OP is equal to 360, right? P to Q is PQ is nothing but 120. So here it is 480. Okay. So a moment. Just a moment. Somebody is coming in now. Okay. So the total path length PL is equal to 480 meters. Okay, the corresponding displacement is what we have found. It's nothing but
240 meters.
240 meters. So what we have seen here, what does the definition say? The magnitude of displacement may or may not be equal to the path length. So here the magnitude of displacement, this is the magnitude of displacement. Okay, it is plus 240. Okay, so this is the magnitude of displacement. Is it equal to the path length?
No, sir.
No, it's not equal to the path length. Why? Why it is not equal to the path length? Because here the motion here, no, from O to P it is okay. From P to Q it travels in the negative direction. Okay, it is a straight line motion only, Mrinalini. Okay, it is straight line motion but in the negative direction. You understand my point? So I am writing like this means it's not in a slanting way. Okay, so it has come from O to P, the first motion, that is OP. Okay, and from here to Q, so it is a straight line motion only. You understand that, Mrinalini? Okay, so you get this. So why displacement is not equal to the path length? Because the motion here involves negative direction, right?
Yes, sir.
Okay, so I understand it right now. Okay, so we'll go to the next one. So next operation is OP plus PO, that is from O to P. Okay, and then from P to O. So first it goes from O to P and then it comes back from P to O. So what will be the displacement? Del x, x2 minus x1. This is the initial position. The car started from here, it went to the P, and from there it came back to here. So this is the final position, that is here. So initial position and it is also the final position. You understand? So initial position is equal to the final position. Yes, Mrinalini, it is 0. Okay. So displacement is 0 since x2 is equal to x1. Displacement is 0. Very good. So what about path length? OP plus PO. What is the path length?
720, sir.
720. Very good. So OP is 360 and P2O is 360. So 720 meters. Okay, right. So we'll go to the next thing. So motion of an object can be represented by position time graph. Okay, so we would have already learned in your lower class also. So what is position time graph? It is like, we call it as, otherwise called as xt graph. Okay, we otherwise call it as xt graph. X is nothing but a position and time is nothing but t. Okay, so here the x-axis, determines the time, the x coordinate determines the time. Okay, we don't have to write x here, so it is in seconds. Okay, and the y-axis, it determines position, x. Okay, so this is t and this is x in meters. Okay, so motion of an object can be represented through position time graph. Okay, so it is otherwise called as xt graph. We'll see about more about, in your NEET and JEE questions you will have graphical problems. Okay, more number of graphical problems will be there. There will be position time graph, velocity time graph, acceleration time graph is there. So we have to see one by one. Okay, so the problems, we'll go into that, when we complete this NCERT, we'll go into that. Okay, so position diagram graph examples we have. Okay, so first example is this, that is, so example is a car. It is a motion of a car. Okay, the first example of position time graph, it represents the motion of a car. Okay, can you describe what it says from this graph? How is it represented? So can you describe this graph? So this position time graph represents the motion of a car. Okay. And what does it say? What does the graph imply? Can anyone try? Yes. Time changes, but its acceleration remains the same. Mernalini, actually, we don't, acceleration, we don't have to. You says time. You're saying time changes, okay, but the acceleration remains the same. But you have to know this x represents only the position, okay, and not acceleration, okay. This x represents, that is in meters, okay, it represents only the position and not acceleration, okay. So it is not that. So anyone?
Sir, displacement changes with respect to time, sir.
Displacement changes with respect to time. So what do you mean by displacement? The same person, can you answer? What is displacement? We have seen earlier, no?
Yes, sir.
Yeah, what is the displacement?
Change in position, sir.
Okay, change in position. Okay, so your name, ma?
Auxilia, sir.
Auxilia, just stay with me, okay? So
Okay, sir.
this 40 and 20, what is it?
Sir, they are the displacement travel, sir.
No, just tell me what it represents. Here, this x-axis, no? This 10, 20, 30, 40, 60, and what does it imply? That
Time,
is,
sir,
yeah,
second.
it is time, seconds, okay. Likewise, in this y-axis, this 20 and 40, what does it imply?
Meters, sir.
Yeah, meters, that is position, okay. You understand?
Yes, sir.
This y-axis, implies position, and the time is in the x-axis, okay.
Yes, sir.
So they have given it is as a motion of a car, okay. So they have, we can describe this graph as a straight line, okay, straight line parallel to the I'll go into that detail again, okay. So here they have drawn a straight line, no, at
Yes,
40 meters, right? They have drawn a straight line at 40 meter, okay. You
yes,
understand? Yeah.
yes,
So you have so what so as I said, it is a motion of a car, okay. So the car is at here, the car is at 40 meters position. The car is at a position of 40 meter, you understand?
yes, sir.
Okay. So at 10 seconds, okay, at 0 seconds, okay, auxilia, at 0 seconds, where is at the car is at where, at which
40
position?
meters.
Okay, at 10 seconds the car's position is at where?
Same 40 meters, sir.
At 20 seconds?
40 meters, sir.
30?
40 meters, sir.
Okay, 40, 50, 60?
All 40 meters, sir.
Okay, so the car is at 40 meters here, that we can say, the car is at 40 meters, that you can say with this line, okay.
Yes, sir.
So the car is at same 40 meters at 10 seconds, 20 seconds, 30 seconds, 40 seconds, 50 seconds, 60 seconds, okay. So you tell me whether with respect to time there is a change in position.
No, sir. Constant position, sir.
Yeah, so there is no displacement, right? So there
Yes,
is
sir.
no change in position. So the body is at
Rest.
rest at 40 meters. It is at rest at the position 40 meter.
Yes, sir.
So the car is at rest at 40 meter. Hope everybody understood this.
Yes, sir. Thank you, sir.
Okay, thank you. What about others? Jai Shri, Shruti?
Yes, sir. Understood, sir.
Understood. Okay, okay. So we'll move on to the next one. So, yeah, just a moment. So, always remember when a body is at rest, okay? When a body is at rest, so the graph will be like, a straight line parallel to the x-axis. You understand? It will be a straight line parallel to the x-axis or time axis. So how do you say when a body is at rest? Like this only. It will be a straight line parallel to the, just a moment, this is the time axis, okay, that is x-axis, time axis, and it will be, the motion will be parallel to the time axis. You understand? So how can you find when a body is at rest due to the graph? It should be a straight line parallel to the time axis. You understand? So once when you see like this graph is given, means when it is a straight line parallel to the time axis, you can say the body is at rest. Okay, so it can be rest at anywhere, like for example, it can be rest at 60 or it can be rest at 20. Okay, but it is at rest. Okay, so when can a body, how can we say when a body is at rest? When we see a graph, it should be a straight line. The graph should be a straight line parallel to the time axis. It should be parallel to the time axis. Understand?
Yes, sir.
Right. So here we have seen, any idea from this, this graph? Any ideas?
Here only change in position with respect to time.
Very good. So there is a change in position with respect to time. So you can see the body is moving right now. So here the body is not moving. Okay, so it is a straight line. Okay, it is a straight line parallel to the time axis. It is at rest. Here the body is moving, right? So there is a change in position, right? Change in position with respect to time, t1, t2, t3. So you are right. Okay, so always remember, when you see a graph like this, xt graph, that is position time graph, inclined at an angle of 45 degree. It is 45 degree only, no? Right?
Yes, sir.
Okay, inclined at an angle of 45 degree, you can straight away say that it is moving with a uniform velocity or constant velocity, or we can even say uniform motion. Okay, when you see a graph, okay, that is inclined at an angle 45 degree to the time axis. Okay, these are just shortcuts, okay, because you are all NEET and JEE students. Okay, so I'm just telling you the shortcuts. Okay, so when you see a graph inclined at an angle 45 degree, okay, to the time axis, okay, then you can straight away say that it is moving at the uniform velocity, with it is moving at the uniform, that is constant velocity, or with the uniform motion. Okay, so I can give you a definition also. What is uniform motion? Uniform motion. Okay, so uniform motion is nothing but when an object or a body, okay, covers equal distances in equal intervals of time. When a body covers equal distances in equal intervals of time. For example, let's say, okay, so this is something like 0 to maybe 10 meters. Okay, 0 to 10 meters. 0, this is 2, and this is 4, and this is 6, and this is 8. All are meters. Okay, and for 0 to 2 meters, what is the distance? 0 to 2 meters, what is the distance? 2 meter, right?
Yes,
Yes.
sir.
Okay, so I'm saying that the body is here, okay, at origin. So to cover this 2 meters, 0 to 2 meters, it takes 2 seconds. Okay, and another thing, from it has come here from 2 to 4 meters. What is the distance? Same 2 meters, right? 2 to 4 meters. Okay, and it takes 2 seconds for this motion also. And here from 4 to 6 meters, to move from the position 4 to 6 meters, what is the distance? 2 meters. Here also it takes 2 seconds. Okay, and likewise 6 to 8 meters, that is also 2 meters. Here it takes 2 seconds. And 8 to 10 meters, that is also 2 meters, that is also taking 2 seconds. So here we can say it covers equal distances, no? 0 to 2 is 2 meters, 2 to 4 is 2 meters, 4 to 6 is 2 meters, 6 to 8 is 2 meters, 8 to 10 is 2 meters. So it covers equal distances, okay, in equal intervals of time. So for 0 to 2 meters it takes 2 seconds, and for 2 to 4 meters it takes 2 seconds, 4 to 6 meters it takes 2 seconds, 6 to 8 it takes 2 seconds. So it covers equal distances in equal intervals of time. 2 meters is covered by 2 seconds, and another 2 meters is covered by 2 seconds, another 2 meters covered in 2 seconds. Okay, so there is equal distances covered by equal intervals of time. You understand? So we can represent this in here also. For example, this is 2, 4, 6 and 8. So here it is 2 seconds, 4 seconds, 6 seconds and 8 seconds. Okay, so here I can say they meet here and they meet. Let's I can come back here. Yeah, so yes, so 0 to 4 and here. Sorry. Okay, this is 8. Sorry, maybe I can extend this line. Okay, this is 8 meters. So you understand this, how this line came, this inclined line. So within this 2 second, 2 meters have been covered, and another 2 seconds, another 2 meters have been covered, and another 2 meters, that is another 2 seconds, another 2 meters have been covered. So the object covers equal distances in equal intervals of time. You understand?
Yes, sir.
Okay. So always remember that uniform, you can always say this as, uniform motion. Okay, you can call it as uniform velocity, okay, and constant velocity also. These are all relatable terms. Okay, so when can we say that uniform velocity, uniform motion, everything is actually equal only? So for example, when we say it is a displacement time graph, okay, displacement time graph. Okay, so what is uniform velocity? So it says it represents, the y-axis represents the displacement and the x-axis time. Okay, so it will be called as the uniform, this graph will be called as a uniform velocity or constant velocity. So the definition is the object covers, any idea, equal displacement, okay, in equal intervals of time. You understand? When can we call it as a uniform velocity? When it covers equal displacement in equal intervals of time. When can we call it as a uniform motion? When the object covers equal distances in equal intervals of time. You understand it?
Yes, sir.
Okay, so both are relatable only. More or less it is equal. Okay, more or less it is equal. And why it is equal? Can anybody tell me why it is equal? I'm saying this is equal to this is equal to this. Why? Just tell me whatever it is, you can tell. Give me just one, we can, for this graph, okay, let's say for this graph, okay, I can say uniform motion is equal to uniform velocity. We can call it as constant velocity also. Okay, we can say, we can call this graph as uniform motion. Okay, sorry, uniform motion. You can call it as uniform velocity also. Can anybody tell why? Anyone?
So the distances are equal to the displacements.
Very good. Distance are equal to the displacement, right? And how distance is equal to displacement in this graph? It is in straight line and it moves in a positive direction, right? Is it right?
Yes, sir.
Okay, it moves in a positive direction. It is also in the straight line. Okay. And one other example, just tell me. I'm writing this graph like this only. Okay. So this is the graph. Okay. So can we call it as, let's say like this. Okay. This is the, so it uniformly goes like this and it uniformly goes like this. Okay. So as you can see, this is a uniform motion from here to here, and here also it is a uniform motion. Okay, right? So here we can say whether the body is moving with uniform motion is equal to uniform velocity or not.
No, sir.
Why? Uniform motion is equal to uniform velocity or not? Why?
Sir, because it changes its direction, sir.
Very good, very good. It goes into the negative direction. So distance will not be equal to displacement. So we cannot call it as uniform motion will not be equal to uniform velocity. You understand it right now? Okay. So we'll move to the next example of graph. So here they have given an example. So as I said, it's a position time graph. X represents the meters positions and time in the that is in the x-axis, time, that is 2 4 6 8 10, the divisions of 2 seconds. Okay, so now let us consider the motion of a car that starts from rest, okay, at t is equal to 0. Okay, so the car starts from here. Okay, the car starts from here. Okay, at time t is equal to 0 from the origin. Okay, they are saying it picks up speed till t is equal to 10 seconds. It picks up speed till t is equal to 10 seconds. Okay, here, see, till 10 seconds. Okay, okay, clear with this till now here?
Yes, sir.
Okay, then they are saying thereafter moves with uniform speed till t is equal to 18 seconds from here to here. From 10 to 18 seconds it is moving with uniform speed. Okay, as we already seen, how will be uniform speed? It is an inclined angle, right? It is an inclined angle. Here it is also an inclined angle, right? It is a straight line, no?
Yes, sir.
Yeah, this slanting inclined straight line represents uniform speed, uniform motion. Okay, then here brakes are applied. Here what happens? Brakes are applied at 18 seconds. Okay, then the car stops at t is equal to 20 seconds here, because it is right only, no? Because here it has come as a straight line. You understand? So the brakes are applied at the 18 seconds. Okay, and what happens here? There is a negative acceleration. Okay, we'll go into that. Uh, because there you have to understand graphs more. Okay, so here the brakes are applied. Okay, and here it comes to rest at 20 seconds. Okay, it comes to rest. Okay, it is a straight line parallel to the time axis. Okay, so here they say that is 296 meters. You understand this graph?
Yes, sir.
Anyone has any doubts on this graph?
Sir, please explain the graph again, sir.
Okay, you just they're saying let us consider the motion of a car that starts from rest. This is rest. Okay, t is equal to 0. The car is starting from here. Okay, So picks up speed till t is equal to 10 seconds. Okay, picks up speed till t is equal to 10 seconds. Okay, so that is from here it is picking up speed till t is equal to 10 seconds. Okay, or else I can explain this once again for you, because wait a minute, this was not given in your book. Okay, you just take this note, okay, so that you can identify the graphs by yourselves. Okay, so let's say this position time graph, or we can say it as displacement time graph. Okay, so here I'll give you certain examples. That is, this is graph 1. Okay, and this is sorry, so this is 1. Okay, this is 2, and this is 3, and this is 4. Okay, and this is 5. This is this displacement, and this is time. Is the graph visible to you, and can you understand what I'm doing here? Or else I can give you, so let's say this is the first graph. Okay, and this is the second one, that is, okay, this is the third one, and this is the fourth one. And this is fifth one. Okay, all are position time, whether it is xt graph or displacement time graph. Okay, so can anyone tell me what is first graph?
Object is at rest, sir.
Very good, object is at rest. Okay, second one,
Uniform motion, sir.
yeah, uniform motion, and I've already told we can say uniform motion or uniform speed or uniform velocity also. What about third one? Can anybody try?
Sir, it is picking up speed and going into rest, sir.
That is third one you're talking about?
Yes, sir. I
Oh,
think, sir.
no problem, no problem. See, what you have to understand here is that this one, the curve, no, this is the curve. We can see like this is the curve. Okay, right? So this curve is towards the, it curves upwards, right? And this curve, it is in the downwards. Okay, you understand?
Yes, sir.
So yeah, here the curve is, is it upwards or downwards? This direction or this direction?
Downwards.
Downwards direction. Okay, so when the curve is in the downward direction, you have to, in a displacement or position time graph. Okay, when the curve is in the downward direction, you have to understand that the graph is decreasing with time. Okay, or we can say that the velocity is decreasing with time. You understand? We can say the velocity is decreasing with time. You understand?
Yes, sir.
So we can say when the curve is in the downward direction, or you can simply keep in your mind like this: in a position time graph, when the curve is like this, okay, it represents that the velocity is decreasing. Understood? Okay.
Yes, sir.
Okay, so in the fourth graph, you can see the graph, it is like this, no? The fourth graph, is it curving in the upward direction or in the downward direction? What about the fourth graph?
Upwards, sir.
Upward direction. Okay, So you can keep in your mind like this, okay? When the curve, okay, curves in the upward direction in a position time graph. Always remember, in a position time graph, when the curve is in the upward direction, we can say the velocity is increasing with time. So does anybody have any doubts in the third and the fourth graph? Because you have to keep this in mind, because you'll be handling problems in your NCERT exemplar also, and also in your JEE and NEET questions you'll have graphical problems also. So you have to keep this in mind. So is it okay? You have any doubts?
Sir, someone has asked to explain fourth one again, sir.
Fourth one again, yeah. Fourth one is nothing but, see, there is only major difference between fourth and third. Okay, what is the difference here? One thing, um, the curve, this is a curve, whether the curve is in the upward direction means, okay, and the curve is in the downward direction, okay, like this. So when there is a curve in this in downward direction, we can say the velocity is in position time graph. I'm always underlining in position time graph. That this does not apply to acceleration time graph or so any other graphs. It is only for the position time graph or displacement time graph. Okay. So when the curve is in the downward direction, okay, the curve is along the downward direction. No, the curve is in the downward direction. So when the curve is in the downward direction, we can say that the velocity is decreasing. Okay. And fourth one, the curve is in the which direction? In excuse me for a moment. Hello, sir. Good evening, sir. Okay, sir. Hello students, are you there?
Yes, sir.
Yeah. So what we were seeing, when the curve is in the upward direction and the curve could be in the downward direction. So here in the third format, the curve is in the downward direction. No, you understand? The curve is like this. Okay. So the curve is in the downward direction. So when the curve is in the downward direction, we can say the velocity is decreasing with time. You understand? Students, are you there?
Yes, sir.
Yeah. So just tell me, the curve is like this in the fourth. Okay. So what happens here? The third, what happens? The curve is in the downward direction. We can say that the velocity is decreasing with time. Okay. What about fourth?
Curve is
Velocity
upwards.
increasing.
That is third, ma. Actually, that is third because the curve is in the downward direction. See the third graph, the curve is in the downward direction. So the velocity is decreasing with time. What I'm asking about, what is fourth? The curve is in the upward direction.
Velocity increasing.
Yes, velocity is increasing with time. Okay. So fifth is nothing but it is an impossible situation actually. You don't have to worry about this. Fifth is impossible situation. It moves with infinite velocity. We can say infinite velocity. Okay, the body moves with infinite velocity. Okay, so having said this, just keep all these 5 graphs in mind and you will understand this. Okay, so tell me first, now let us consider the motion of a car that starts from rest. So where it starts? Here only, no?
Yes, sir.
Okay, so our time we have come till here, no? So now let us consider the motion of a car that starts from rest at time t is equal. So the car is at here. It has started from here. Okay. So they are saying it picks up speed till t is equal to 10 seconds. Picks up speed till t is equal to 10 seconds up till here. So I'm saying like this. Picks up speed. So what does it mean?
Velocity increases.
Very good. So the velocity increases. So you're right. So you understand right now. So they are saying between 0 to 10 seconds, the velocity is increasing. So automatically the graph will be like this. Let's say this is 0 and this is 10 means it should be like this. The curve should be in the upward direction. Is the curve here upward direction between 0 to 10?
Yes, sir.
Yes,
Okay.
sir.
Yes. So it picks up speed means what? Velocity is increasing only, no?
Yes, sir.
Okay, so clear everybody. So from 10 here to 18 seconds, you are saying it is moving with the uniform speed from 10 to 18. Let's say here, it is moving with the uniform speed. As you already know, what is uniform speed? It should be a inclined straight line, right? It should be an inclined straight line. Okay. So as you can see, it is an inclined straight line now. Is it an inclined straight line or not?
Yes,
Yes, sir.
Like you can just take only this motion alone. For example, let's say this is 10 and this is 18. Okay, so it is like this. You understand this motion? I'm
Yes.
writing, I'm just drawing graph for just this motion. So between 10 to 18, moving with the uniform speed. You understand right now?
Yes,
Yes,
sir.
sir.
Okay, then what is the third they are saying? Then the brakes are applied, right? Then the brakes are applied. So what happens when we apply a brake? We are going at a speed of 60 km per hour means if you are applying brake, what will happen?
Speed decreases.
Very good. So the velocity decreases, right? So how to describe the velocity decreases in a graph? curve will be like this, right?
Yes, sir.
Understand everyone?
Yes, sir.
Okay, so the brakes are applied, so you can see that the velocity is going to be decreasing. Okay, so here the brakes are applied, then the curve is like this. See, you understand
Yes, sir.
the curve? See, can you see the curve here? It is in the downward direction. You understand right now?
Yes, sir.
Okay, so here it comes to rest. What is rest? We have seen now. Straight line parallel to the time axis. So brakes are applied and the car stops at t is equal to 0. Here to here. It is a straight line. Straight line. So it is rest. You understand right now? Do you have any doubts?
Understood, sir.
Okay, everyone?
Yes, sir.
Okay. So you understand the graph. Okay. So yes, thank you, Mrinalini. We'll just see this question and we'll just wind up this class. Okay. Tomorrow we'll continue. Tomorrow we have class actually. Okay. So tomorrow we'll continue. So what about this? Do you have any idea? It is your book back exercise only. So that is a position time graph of two children's A and B. A and B two children returning from their school O. So O is the school, okay, and returning to their homes P and Q are shown. That is A's school. That is A's house is at P and B's house is at Q. Okay, choose the correct entries in the bracket below. First one, whether A or B lives close to the school than B or A. What is first one? They have given a position time graph. Okay, so they have said A and B are two children. A lives at P. Okay, this is A's house. Okay, and this is B's house. Okay, so what they are asking, first option, whether A or B lives closer to the school than B or A. So who lives closer to the school actually? So of course it is A, no?
Yes, sir.
O is the school. So this is A's house. This is B's house. So obviously A lives closer to the school than B, right? So you can write as A. A lives closer to the school, okay, than B. Okay, and the B option, A or B starts from the school earlier than B or A. So who starts earlier from school? So two children, A and B, are returning to their homes, respective homes from their school. Okay. So who starts earlier? Whether A starts earlier from school or B starts earlier from school. Okay. This will be easy for you. Say this is, say for example, this is 0 second. This is 1 second. This is 2 second. This is 3 second. So now tell me who starts earlier from school. 0 is the school.
Yes, sir.
A. Because he starts instantly. B starts after some time only, right?
Yes, sir.
So A starts earlier from school than B. Okay. What about C? That is A or B walks faster than B or A.
B works faster, sir.
Yes, B walks faster. Okay. As you can see, we have seen no in the graph here. What did I say? This graph, and the body is moving with infinite velocity. But here it is not moving with infinite velocity, but it is moving with a very high velocity. B moves with a very high velocity or very high speed. Okay. So B walks faster than A. B, that is for the C option. B walks faster than A then, right? So what about D? A or B?
Different times.
Different time. Okay. Actually, you know, like in some books, it will be like, it should be like this. Okay. Okay. Actually, the correct format of this is like this, that it should be reaching at the same time. You understand? So that is the correct format actually. Okay. But the graph given here is slightly changed. Okay. So Auxilia, na? Auxilia only answered or anybody else?
Yes, sir.
Okay, okay. So according to the graph, what you said is right. Okay, because since it has not touched P, right? It has not touched the line A, does not touch P. Okay, but in original books, it has to be, it will be in the same like this one. Okay, P will be okay. So they'll
Yes.
be reaching at the same time. Okay, same is the correct answer, but not according to this graph. You understand?
Yes, sir.
Okay. So what about E? A or B overtakes B or A on road once or twice. Who overtakes who, whether it is one time or two times? It happens once or twice. See, A has started from here. It is moving with, let's say, uniform velocity, right? So this is A, no? Right? It moves with the uniform velocity, right or not?
Yes, sir.
Okay. So this is B. It moves with higher velocity, right? Than A. Okay. So here, which is higher? The velocity wise, B is higher. Okay.
Yes,
B
sir.
has high, B has very large velocity. Okay. So whether it overtakes A or not?
It overtakes.
Yes, it overtakes A. Okay. So it has started earlier. A has started earlier, but B has started at a later time, but with a higher velocity. So it overtakes A at once. Okay, at once only. Okay. So B overtakes A at once here. Okay, at the point of intersection of these two lines. Okay.
Yes, sir.
Okay. So are you guys clear with this today? Whatever you have seen, you're clear?
Yes, sir.
Yes,
Okay.
sir.
Okay. We have class tomorrow also.